The contractors across the street are on lunch break, so it'll be perhaps a little more quiet. We're going on to topic 4 of chapter 3, slope and rate of change. Now, when I used to lecture on this, I'd say, well, what's slope? You know, and if you want to go skiing, you're looking for a nice slope that you can go down. And then if you're going to move a barrel or something up, you want to have that little slope, like the handicap provision that helps people go over curbs and into buildings. And you don't want it to be too severe. But what is slope anyway? Well, slope, by definition, we use the lowercase letter m to indicate slope, is a ratio of rise units over run units. So that when we're making these graphs, our vertical rise would be y units, horizontal would be x units. So rise over run is a ratio of y over x. And as we've indicated earlier in our formula for slope, this is what it is. If we have two ordered pairs, like we show here, we can figure out the slope. Now, it doesn't make any difference which ones that you say are x sub 1, y sub 1. But once you designate it, then that is it, and then you can't interchange. So I always like to use this one as our y sub 2, which is 6. So I put the 6 right there. Minus y sub 1, which is 2. So y sub 2 minus y sub 1. Negative sign is in the formula. And then we go x sub 2, which is 4, minus x sub 1, which is 1. And that gives us a 4 over 3. So our slope of this particular line is 4 units vertical, 3 units horizontal. In fact, you can actually pick them out here. Drop that down here to here. There's 3 units. And from there to there, there's 4 units. So there's 3, and there's 4. So we can often look at a graph, if we can pick out where it's going through the grid, and we can tell the slope right from the graph. But they're going to give us some examples to work with using this formula. Okay, well, let's go on and do some. And these will be our 2's, our 1's. So it'll be negative 3 minus 5, 2 minus, now this is tricky because minus is in the formula, so I usually put a parenthesis here, minus 1. So what did we know from chapter 1? When you have like 2 negatives, this will become a positive. So this is going to be a negative 8 over 3. That's the slope. And remember, there's an m here. And for this one, it's going to be 4 minus, again, a minus 2. Minus is in the formula. And then 2 minus a minus 1. And you want to be careful about your signs. So this then becomes 6 over 3, which we reduce to 2. Now they want us to graph these two, and I'm assuming you can put that into your graph and make the graph. But we're particularly interested here in finding the slope. Now, in example 3, They want us to look at this special formula, which we've already identified as slope-intercept formula. Why? Because this is the slope and this is our y-intercept. So they want us to look at this formula and pick out the slope. Well, the slope is going to be the numerical coefficient of x, which is 3/4. And our y-intercept is going to be 0,6. So there's our slope, there's our y-intercept. Now, for example 4, as we look at it, you might say, oh, our slope is 5. No, that's not. Because this is a negative y. We have to have y as positive. So I'm going to divide everything by a -1. That just reverses all the signs. So by dividing every term by a -1, we just reverse the signs. So now, what's our slope? Our slope is -5. Now remember, that's -5 over 1, because it's a ratio of y units to x units. And our y-intercept is 0,2. Here we're going to show you technique. Now, example 5 is in standard form. In order to easily pick out the slope, we have to solve for the letter y, a positive y. So I'm going to move the y over to this side to get it to be positive. Move the 4 over, it becomes negative, and then I have 3x. Now I'm going to divide everything by 4, and I'm going to rewrite it this way. So it's y equals 3/4 x minus 1. So our slope then, once we solve for a positive y, is 3/4. Now, for example 6 and 7, they give all the details in our textbook. And I don't want these tapes to get too long, so I'm just going to tell you the answer. That whenever you have a horizontal line that's in the form of y equals b, the slope is 0. And anytime you have an equation in the form of x equals a, that is a vertical line, the slope is undefined. Now what does that mean? Quickly, it just means that when you use this slope formula, you ended up with something like 3 divided by 0. This bottom became 0. We can't have a denominator that's 0. Anytime we have a denominator that's 0, it is undefined. So in this case, the slope is undefined. And when we did this one, it ended up as 0 in the numerator over, let's say, 4, or whatever number you happen to get. So 0 divided by any number other than 0 is 0. So these are special cases. Horizontal lines, the slope, 0. Vertical lines, the slope is undefined. Rather, to go on to something new right now, we're going to, or new examples, we're going to do a little review of some of this stuff, parallel and perpendicular lines. But before we finish the previous section on slope, a good little summary of what slope is. If you see a line that starts low on the left, and as you go to the right, it goes up, that's positive slope. If you start at the left and it's high, and as you go to the right, it goes down, that's going to be negative slope. If you see a horizontal line, that's going to be zero slope. If you see a vertical line, that's going to be undefined slope. Now, another thing, I've added two little numbered things where they're not so much formulas, they are definitely hints. And that is, if the slope of one line is equal to the slope of another line, but the y-intercepts are different, then those lines are parallel. That is, they have the same slope, but different y-intercepts. The lines are parallel. Now, in number 8 here, it's saying if the slope of one equation multiplied by the slope of the other equation, and the product is a -1, that is, the slope of one is 1/2, and the other is -2, or 2/1, which gives you a product of -1, the lines are perpendicular. So this is background of how we're going to do these next few examples. So we use this information to look at equations and to see, is this set of equations, are they parallel lines or perpendicular lines? And they give us 3 examples. And again, you're looking for strategy of what to do. Well, basically, all of this relates to comparing your slopes. So here, this is in slope-intercept, so we know this slope is a -1/5. So what's the slope here? Well, it's going to be 10y equals, transpose that, divide everything by 10, and then here we get y equals a -1/5 x plus 3/10. So here, this slope is -1/5. This slope is -1/5, I just reduced it here. And the y-intercepts are different, so these lines are parallel. Again, we want to find out what the slopes are. So y equals -x plus 3, I converted that, transpose it. This is going to be y equals x plus 4, transpose that. So what's my slope? Well, here, this one is a -1, and this one is a +1. Now, if we multiply these slopes, what do we get? We get a -1. So, are these lines perpendicular? Yes, they are perpendicular. All right, in this one, now I solve it for y. Y equals a -3x plus 5. That's this equation, just transpose it. Here, this is 3y equals a -2. I'll do that later. 2x plus 6. So divide everything by 3. I get y equals a -2/3 x plus 2. And now I'll compare my slopes. Well, here I get a -3, and here I get a -2/3. So for this one, it is neither. It's neither. It's neither parallel nor perpendicular. Again, if the slopes are the same, formula 7 there, y-intercept's different, lines are parallel. If the product of the slopes is a -1, which is what it is here, it's perpendicular, and if it's not those, it's neither. Okay, for an introduction to this, next to the last topic, we're talking about slope as rate of change. So if you're driving up an incline, that for every 100 feet, it goes up 7. What is your rate of change? Well, again, we're using the standard of slope is y units over x units, or rise over run. So this is simply going to be 7 over 100, which is 7%. And for example 9, here it's 15 feet, 250, so 15 divided by 250. Put that in your calculator, you get 0.06, so that would be 6%. And for example 10, they're saying if you have data, and the chart in your textbook's a little more elegant than this, this is 1990 and you have this much time and amount, can you figure out the slope of that line? We're going to need this in the next chapter, and the answer is yes. Just use your slope formula, and you get 357 over 21, which is 17 over 1. So the slope, normally you would just use the upper part, but keep in mind, every number, without a number in its denominator, there's a 1 there. Okay, well this wraps up section 4 on slope. Good luck to you, and again, try to keep up to date with your practice and quiz bees.